Hey guys, welcome back to another RASK Maths tutorial, and in this tutorial I'm going to be explaining how we can calculate the nth term of a quadratic sequence. So previously I showed you guys how to calculate the nth term of a linear sequence. I'll just show you that right now. So a linear sequence is something where the terms increase by a fixed amount every time. So in this sequence you can see that adding plus 2. And the nth term of this is really simple. We just look at the difference and then substitute in for the first value. So in this case, the nth term is going to be 2n plus 1. That was a linear. But a quadratic is slightly different because in a quadratic sequence, the terms aren't going to be the same length apart. So let's say this is the quadratic sequence we have. So we have 1, 3, 7, 13, 21, and let's have 31. Okay, so let's look at the difference first. Okay, so you can see the difference between each term is actually not constant anymore. We have plus 2, plus 4, plus 6, plus 8, and plus 10. But one thing you might notice is that the difference between the difference of each term is constant. So that's the fact which we're going to use. And I'm going to show you guys how we can work out the nth term. So it's slightly more complicated. And the first thing you want to do is you want to find the differences. So in this case, we can just look at the first row here. But what you want to do is we're going to assume that the nth term is of the form an squared plus bn plus c, and we want to find a, b, and c. So that's what we're assuming, and we assume that because we're presumably given that it's a quadratic sequence, so we can assume that's true when we're given this. And once we're given this, we can find a using the first equation. So let's write this down. The first equation we're going to use is 2a equals the second difference. So what I mean by that is this second difference, so you go from the first term to the second, and then the difference between that difference, that's the second difference. So in this case, 2a is going to be equal to 2, which gives a is equal to 1. So that's the first equation which you need to remember. Now the second equation is 3a plus b is equal to the first difference. By first difference, I mean just the jump from the first term to the second term. So in our case, that's also going to be 2. So we've got 3a plus b is equal to 2. We know a is equal to 1, so therefore 3 plus b equals 2. So b has to be minus 1. There we go. We've got a and b so far. Now there's only one more equation that we need to know to work out what c is, and that is a plus b plus c is equal to the first term, or zeroth difference, if that makes sense. So by first term, I think it's fairly clear. I just mean this 1. And in our case, that means a plus b plus c is equal to 1. We know a is 1, b is minus 1. So that becomes 1 plus minus 1 plus c equals 1. These cancel out, which means c is equal to 1. So we've got our three variables which we were trying to find. And now that gives us that t is equal to 1n squared, or just n squared, minus 1 times n, which is just minus n, plus 1, like so. So here we go. This is the solution for the above. Let's check if that works. Let's look at the fourth term, or the third term, 7. So when n equals 3, we're going to get t equals 3 squared minus 3 plus 1, which is 9 minus 3 plus 1, which is 7. And you can see that is correct. So we've managed to formulate the correct quadratic sequence for this sequence. Now, I can explain why this works. It's a bit more complicated, but I will do it. Okay, so first of all, we're going to assume that sequence is of the form an squared plus bn plus c. That's what we assume. That's what you can assume if you're told it's a quadratic sequence. So now we know the first term is going to be, just put n equals 1 into here, you get a plus b plus c. The second term is going to be, when we put n equals 2 into this, you get 4a plus 2b plus c. The third term, that's going to be, put 3 into this, 9a plus 3b plus c. And that continues like so. Now, if we look at the jump, so the jump from this to this, well, the difference between these two is 3a plus b. When you subtract 4a plus 2b plus c minus a plus b plus c, you get 3a plus b. And the jump from this to this, well, that's clearly 5a plus b, since subtract this from this, and you will get 5a plus b. And then this continues on like so. And the jump from the second difference, so this first two differences in the first row, well, the jump between those, that's just a constant at 2a. So hopefully you can see where these formulas came from now, because these are the three equations I told you to memorize earlier, and that's how we've ended up with 2a equals this second difference up here, 3a plus b equals the first difference, and a plus b plus c equals the first term. It comes from calculating the general solution and then just mapping them to whatever quadratic sequence you have. So thanks for watching, and that was how you work out a quadratic sequence, a quadratic nth term. See you guys in a future tutorial. Bye.